My name is Isaiah Francis, and this is my idea of adding a modular component to wastewater treatment facilities. Wastewater treatment is essential for maintaining the health of the public. Without wastewater treatment facilities, imperfections could make their way into natural bodies of water and even drinking waters of communities. This can cause many health problems as well as environmental problems around the community. Although it is very important to manage wastewater, many small communities struggle due to inadequate or outdated systems. In a lot of small communities around the world, wastewater treatment is either outdated or non-existent, and this is a huge problem. A lot of these communities rely on very basic treatment methods, which are not sufficient to meet today's health or environmental standards. Without proper treatment, the public's and environment's health is at risk. Additionally, implementation of these systems can cost a lot of money to build and to keep in operation. There's a critical need for more affordable and easier to operate system that can manage the wastewater as well as reduce energy consumption, which is why the implementation of engineering is necessary. A solution to this problem is a modular wastewater treatment system. This system will use a combination of natural filtration techniques as well as renewable energy. It will be scalable and cost efficient, allowing it to be affordable for small communities in need of a new system. The system is very flexible and can be easily scaled to the necessary size of the community to allow for easier maintenance. Civil engineering, mechanical engineering, electrical engineering, and biomedical engineering all play a huge role in the system. Civil engineering plays a central role in designing the modular units. Each unit will use a natural filtration process to break down organic waste. A possible process could be biofilters. Because the units are going to be modular, they will be easily scalable for different size communities. Additionally, the civil engineering will design infrastructure for the collection and redistribution of the water. They will be able to ensure that a lot of energy is not necessary to maintain the system. Next is mechanical engineering. A mechanical engineer's main role on this project would be to make the system autonomous and energy efficient. Mechanical engineers will design low power costing mechanical pumps as well as aerators to circulate the water during treatment. This is essential for ensuring the system will remain cost efficient over a long period of time. By also focusing on autonomy, very little human intervention will be necessary to keep the system running. This is very important because, especially in communities with limited resources. Electrical engineers, on the other hand, would focus on smart sensors and renewable energy sources. With the implementation of smart sensors in the treatment process, key indicators like pH level and turbidity will be able to be monitored in real time. This data can be sent in for remote monitoring and management. This feature will allow a community to track the performance of the system and ensure the public's health is not at any risk. Electrical engineers are also in charge of powering the system with the implementation of wind turbines and solar panels. By adding a renewable energy source, we can ensure that the system will be cost efficient and allow for to be located at off-grid locations. Finally, we have biomedical engineering. Biomedical engineers will oversee the integration of biosensors for water quality testing. By detecting harmful pathogens in real time, we can ensure that the treated water is safe for its reintroduction into the community. With this, we can make sure the water is safe for consumption and that it meets health standards. I believe this is a perfect solution to the problem of wastewater treatment. It is scalable, sustainable, cost-effective, and has energy independence. During my time in the 4 rotations, I learned many principles and ideas that were necessary for making a system like this work. During my time in civil engineering rotation, I learned that the techniques required for wastewater treatment and how to look for it and what to look for in the water to make sure it is safe and drinkable. I was then able to use my knowledge from the other rotations to assign the roles necessary for each step of the process. By integrating principles that I learned in each of the 4 rotations, I was able to design a system that is environmentally friendly and very effective in treatment of wastewater. This solution can be implemented in many countries around the world due to its scalability and cost efficiency. Thank you for watching. My name is Isaiah Francis, and this is my final project for Introduction to Engineering Experience Lab 1206.